So I want to try to address what the price of electricity is under my model. Okay, so in recent days, it sounded like I'm anti-dynamic pricing. Okay, I'm not. I'm just disagreeing with the implementation of dynamic pricing, where it comes out as the result of a static optimization problem, which assumes that the market is at steady state or the market is at equilibrium. So that's what traditional dynamic pricing is, where the price is updated every minute, every 5 minutes, every 15 minutes, every hour. We solve an optimization problem and we get the prices as the dual variables of the optimization problem. That gives you a time series of prices, and the time series can change every 1 minute, 5 minutes, whatever you have. I'm saying let's not do that. So what that guarantees is that you have the same price for the same group of people at a particular location. So you can do nodal pricing, you can do whatever. And that is one of the core arguments that I'm making. So I'm saying it's not necessary. So you could have two neighbors in the same, they could be next door neighbors. They don't need to pay the same price. Why would they pay the same price? So under my system, it depends. So I'm processing every request sequentially. So neighbor one puts in their request, neighbor two puts in their request, and I'm choosing from the backlog of requests and I'm processing each one sequentially. So I'm not waiting for a clock to happen. So that's the difference, where you have a synchronous optimization problem that's being solved on a clock. It's being solved every 1 minute, every 5 minutes. I'm not doing that. I'm taking a request and I'm processing it, okay? And then I'm moving on to the next request. And that means that you could have neighbors who live in the same place that could end up with different prices. And that's controversial for electricity. So what that means is you don't actually have a time series of prices that's guaranteed as a static time series. So you don't have the price of electricity at midnight is X. The price of electricity at midnight plus 1 minute is X plus delta. What you have is the price of electricity for neighbor A is this, and the price of electricity for neighbor B is this. That is, so if you consider a pricing function, that's a dynamic way to determine a pricing function. It's not a static price. Price is changing with time, but the variable that it's changing with is not time itself. Well, it's changing with time, but it's also changing with the request, okay? And I have this defined at every point in space and time. So it's changing in space and it's changing in time based on as and when requests are changing. And there's no reason we can't do that. We have all the data to do that. But importantly what that does is it gives you dynamism, true dynamism in the system. So with dynamic pricing as a static optimization problem, what you do is you're shifting the problem. So you can create new peaks. You just shift the demand to where so it creates a new problem. So if you have a dynamic price and all neighbors on the same street are on the same tariff, and you might say that's unlikely, and you might be able to say random things like, oh, we'll make sure that every tariff is staggered so it doesn't change. I mean, that's all bullshit. What I'm doing is how you solve the problem properly. So I am very pro dynamic pricing, but the argument I was trying to make is to say dynamic pricing applied to everyone, which is kind of what the debate is looking at in the UK. It's sort of saying everyone should have a smart meter, everyone should have a dynamic tariff, or they have a static tariff where the energy doesn't change at all, or the cost of energy doesn't change at all, but it would be more expensive. So what I'm saying is, no, let's just apply the dynamic, let's size the system properly so that we're not like doing random crap to try to get an extra 100 watts of flexibility when the admin cost of actually doing that is more than the value of the flexibility that we're actually going to be able to access from the system. So what I'm saying is just apply the dynamic elements of the tariff in the way that I described, which is determined by an automatic market maker. just apply them to specific devices rather than applying them. And if a retailer wants to apply it to at the meter level, they can do that. You can still offer a dynamic tariff. What I'm saying is, if you're applying it by default to people's electricity, their heating and their sort of basic consumption, you risk the backlash of people actually participating in the system in the first place. Because there's costs involved in the energy transition to adapt the system, to build renewables, to build the grid, to build this new market infrastructure. So you actually need people pay taxes, people need to pay their energy bills, people like start a protest to say, oh, I'm not going to pay my energy bill due to this media backlash, whatever. So you need to bring people with you on the journey, is the point that I'm making. We can't just assume that people are this econs. They're actually humans. So we have to take behavioral science into account, and we have to design the system in such a way that it builds trust, it builds fairness, it builds knowledge.